Okay, so we're trying to find, remember this doesn't mean square, this means find the second derivative. So we need to find the second derivative. So the first derivative, since 3 is the constant, we're going to leave it alone. Find the derivative of sine, that's cosine of 6x, times the derivative of the inside. And the derivative of 6x is 6. So we're going to have 18 cosine of 6x. The second derivative, again, 18 is a constant, so we're going to leave it alone. The derivative of cosine is negative sine of x, or negative sine of 6x, times the derivative of the inside, which is 6. So we're going to have 18 times 6 times negative 1, so negative 108 sine of 6x. And that would be my second derivative. Okay, so we're trying to find the derivative of pi over 4. Remember for the non-calculator parts, you need to know all of your trig functions for pi over 4, pi over 3, and pi over 6. So the derivative of sine of x is cosine of x. So as we substitute pi over 4, we have cosine of pi over 4, and cosine of pi over 4 is the square root of 2 over 2. If the limit at x goes to 3 of f of x equals 3, which ones must be true? Okay, f is continuous at x equals 3. That's not necessarily true, because if my limit exists when x equals 3, okay, here's 3, here's 7, I can have something like this. Okay, the limit exists because when I come from the left and when I come from the right is 7, but it's not continuous because I have that open circle. F is differentiable. No, for the same reason. In order for it to be differentiable, it has to be continuous. F of 3 equals to 7. Nope, because I just drew a graph where the point does not exist when x equals to 3, the point doesn't exist. So none of these are necessarily true. A particle moves along the x-axis so that the time greater than the road's position is given by my function x of t, at what time t is the particle at rest. Okay, well the particle at rest is when the velocity is equal to 0. And the velocity is the derivative. So what we need to do is we're going to take the derivative and set it equal to 0 and solve for t. We're going to have 6t squared minus 42t plus 72. Okay, we're going to set that equal to 0. And factor out is 6. So we're going to have t minus 4, t minus 3. So we're going to have t equals to 4 and t equals to 3. So either one of these, my particle is at rest at t equals to 4 and t equals to 3. Okay, find the derivative of the function. To find this derivative, we're not going to use the quotient rule because 3 is a constant. So when it's a constant, it's just easier to rewrite it. So I'm going to rewrite it as 3x to the negative 6. That makes 3 a coefficient. So when I'm trying to find the derivative, I just leave it alone. So I'm going to multiply 6 times negative 3 times negative 6 and subtract 1. So that's going to give me negative 18x to the negative 7. So my derivative is negative 18x to the 7th. Use the following information about f and g to find a, b, and c. Okay, so let's start with a. We need to find the derivative at 1. So since I have a quotient, I'm going to have to use the quotient rule. We're not going to substitute 1 until the very end. We have to find our derivative first. So derivative of u is f prime, and the derivative of v is g prime. So the quotient rule is the derivative of u times v minus the derivative of v times u all over v squared. Okay, so we're trying to find the derivative when x is 1. So my derivative here, f prime of 1, g of 1, minus g prime of 1 times f of 1 all over, sorry, that should be g of x squared times g of 1 squared. So f prime of 1, it's f prime when x is 1 is 3. G of 1 is when x is 1, g is 4. G prime of 1 is 4. And f of 1 is 2. And finally, g of 1 is 4. I'm going to have 12 minus 8 over 16. 4 over 16. So for A, my answer is 1/4. Okay, for B, since f of x is g of f of x, we're going to have to use the chain rule. F prime would be the derivative of g, so that's f g prime of everything in the inside stays the same, times the derivative of the inside, and the derivative of f prime. We're trying to find the derivative at 3. Okay. That's going to give me g prime at 3. It's 3. Actually, sorry. First, I have to find f of 3. F of 3 is 1. F prime of 3 is 4. And g prime of 1 is 4. I'm sorry, there should be a times here. I don't know where I got the plus. So 4 times 4 is 16. Okay, so C, move this a little bit. So C is find the derivative. Okay, so before I do this, I'm going to rewrite as 3f of x plus 2 g of x squared, because that shows me that I have to use the chain rule there. So p prime of x is going to be 3 is the coefficient, so I leave it alone. So it's just going to be f prime. We're going to have to do the chain rule, the outside, so it's going to be 4 g of x, subtract 1 to the 1, times the derivative of the inside. We're finding the derivative at 2. Okay, so we're going to have f prime of 2, which is 3. G of 2 is 2 and g prime of 2 is also 2. So we have 9 plus 4 times 4, which will give me 9 times 16, which is 25.